So scale drawings work, but they're time consuming and we have to be able to do it with calculations. So the first thing that you're going to do is you always draw tip to tail. So it will give you one direction. You start in that one, and then when you change direction, your new starting point is the arrowhead of that last line that you drew. Okay? So if I was going to draw something that was, let's say, 45 degrees north of west, when I look on a Cartesian chart, north of west is this way, so 45 degrees. And then let's say we went, I don't know. From there we went, let's say we went 1 kilometer, and then we went 5 kilometers due east. That's our two directions. Well, my first line that I would draw would be the 1 kilometer, 45 degrees north of west. And then I would go 5 kilometers due east. North of west. Let's change this to north of east. Okay, so this is tip, this arrowhead piece, and this is tail, the starting of the arrow. So tip to tail. That's how we draw it. And then when we're looking for something, this is our resultant vector here, from where we started to where we ended off. Okay? And we use trig. And we're going to start off easy. We're going to work on the 90s. So we're learning to drive a standard. How many people here can drive a standard? Only me? God. Paulina, don't you know how to drive a standard? Kind of. Farm girl? Okay. You drive 165 kilometers south, and then you turn and drive 214 meters east before you decide that you had enough for one day. 165 meters. This whole learning excursion took you a total time of 2 hours. What's your total displacement, and what is your average speed? So first things first, you get a mark for this, draw the picture. It says we went 165 kilometers south, or meters, south. And then I turned and I drove 214 meters east. Always draw a picture first. And notice that my 165 meter line is shorter than my 214 meter line. Is it to scale? Absolutely not. But I understand the gist of it. I went further east than I did south. And so what it's asking us in total displacement is not the sum of what I traveled, but the overall, right? So I want to know from here, where I started, to where I ended up. That's my resultant vector. So then it says, first one, what is your total displacement? Well, this is an easy peasy one because we can use Pythagorean theorem to solve this. And what is that? How do we use Pythagorean theorem? Right? It's not asking us for the square displacement. So our answer is actually going to be the square root of a squared plus b squared is equal to c, because the opposite math function of squaring is square rooting. And so then I can look at this and I can go 165 meters squared plus 214 meters squared is going to give me my displacement. And so Avery, I'm going to ask you to calculate, and Paulina or Rebecca, I'm going to ask you to fact check it. And when you're using a TI 83 or 84, any version of, make sure you go square root, or you go 165 squared plus 214 squared and then the equal sign and then square root that answer. Or if you want to do it all in one shot, you do the square root symbol and then you make sure you use your brackets underneath. Because what it will do is it'll do the square root of 165 meters squared, and then it will add it to 214 meters squared. So you have to tell the calculator step by step what you need it to do if you want to do it all in one line. Plus 214. So do you want to do it all in one line? Okay, so you're going to go the square root symbol, bracket, 165 squared plus 214 squared, and bracket. .270 point which? Okay, we'll go there, meters. Now, because we're not in a straight east or a straight south direction, we actually need to figure out what angle is that displacement at. And this is the angle that we're looking at because we started here and we ended here. So we always want it from where we started. How do I find this angle? Well, and I use trig. I have this lovely rhyme. It's the only time I ever use a rhyme or a trick. Now, I don't have an angle. I'm looking for an angle. I'm looking for this angle. And the easiest one to use is tan. So tan theta is equal to opposite over adjacent. But I want the angle. So in order to solve the angle, I'm going to go tan -1, or the inverse of tan on your calculator, multiplied by opposite over adjacent. So I will show you. You should have done this, but that's okay if you haven't. I will show you. Okay, battery is low. Well, it'll last long enough for me to get this done. So when I want to do this, I'm going to hit my second key. Move this up a little bit. And hit my second function key and then my tan button so that I can get that tan inverse symbol. And then my angle opposite of that angle is 214 meters. And then I'm going to divide it by my adjacent angle, which is 165. I'm going to end my brackets, and I'm going to get okay. Are you guys able to follow that step by step? So now I got to put this all together. Now let's go back to the question. How many significant digits in the distances that are listed? How many? 3. So 1, 2, 3. This 2 is the only thing that can have an effect on the value. Does 2 do anything to 270? No. So I've got 270 meters. And then this angle here, we need to look. See if I can. Here's our Cartesian plane right here. So it's 52.4. Now the thing with angles, I don't care if it says 165.83 meters. Do not give me 52.367. Just give me angles to one decimal. We can't get any more accurate than that. Always. It doesn't matter what the sig digs are. You can give me 52, but don't ever give me more than 52.4. Okay? Degrees. And so this angle here, if we were to go this way, it would be east of south. You can't see. Nobody said. Okay? When you go this, let's look at some of these problems just so we can get familiar with it. So if we turn to page 112 in our question pack, and we want 1A. It says solve for the unknown angle or x for each of the following right angle triangles. Place your answer in the blank to the right of the question. So this one here, this is asking for displacement. So Kyle, you're going to solve A. Cameron, you're going to do B. Paulina, you're going to do D. And Princess, you're going to do E. Do you need a calculator, Rayleigh? Daniel, do you need a calculator? There's some in the drawer there. Is there another one in there, Gus? Did it work? No? Needs another battery? That I might be able to solve. mine, but apparently it's got a charge. Okay, Rebecca, did you get? Okay. Kyle, did you get? What one did you solve? A. What'd you get? You got how much? Me too. Cameron, did you get? Well, I thought Rebecca would have done, oh no, Kyle would have done A, you would have done B. But if you did D, that's okay. Okay, what'd you get? 40 degrees? Yep, because the 9 rounds up, right? Okay, but we need a direction, Cameron. This is your east, that's your main axis. Because you have to go south from this hypotenuse to get to east. It's a reverse angle. This is a hard angle to see. We solved this one here, right? And so this is our main axis. East is our main one. Typically, south of east looks like this. This is typically what south of east looks like. But this is a reverse angle. And so if we were to flip this triangle up, we would have this angle. It's okay. This is a hard one to see. Paulina, what did I ask you to solve? Which? D, E. Say a word that starts with that letter. Dog, D. Okay. Princess, what did I ask you to solve anything? E. What'd you get? I got same thing. What'd you get for an angle? Like a direction. Yeah, it's the same one. Okay, B. This one here, it's asking us to solve this one here. That's why I wrote these different pieces up here. This is A, this is B, and the hypotenuse is C. So it's asking us to solve the A value here. Okay? And so all you do then is you have to just manipulate the formula, rearrange it, and then solve for it. And so I'm going to go 8 squared minus 6 squared, and then I'm going to take the square root of all of that, and I got 5.3. Did anybody get a number the same or different than me? Same, Princess? Anybody else? Because some of them are asking us to find the angle. D, E, and F are asking us to find the angle. And A, B, and C are asking us to find the side length. You have a question, Rayleigh? No? You're good? Cameron? Absolutely. Am I a thumbs up, a thumb sideways, or a thumbs down on this? I got one up. I got a couple sideways. Yep. C? It's asking us to find this length. Remember, this is A, this is B, and this is C. But I have an angle, and it's asking me to find this one. So this angle here, I would use one of those ones, right? This is opposite of this angle. Oh, that would be hard to understand what I'm talking about then if you couldn't see. This angle right here is 35 degrees, right? This A is opposite, B is adjacent, right? So I have opposite over my hypotenuse. Which one of these would I use? Right, I would go the sine of 35 degrees is equal to opposite of 5.0 millimeters. We got to put units in here. And then I would just simply go the sine, can you see my calculator? The sine of 35 degrees multiplied by 5, because when I rearrange that, that's what this would be, right? Sine of 35 multiplied by 5.0 is equal to my opposite. And so this would be 2.9 millimeters. Does that make sense, Princess? Kinda. I went really fast. This is the sine of 35 degrees, right? Sine is equal to opposite over hypotenuse. So my opposite is my x. That's why we chose sine. My hypotenuse is 5 millimeters. When I isolate for just 5 millimeters, it's sine times by 5, right? Because to get 5 out of the denominator, I have to multiply both sides by 5. So it'd be sine of 35 degrees multiplied by 5 will give me my opposite. And so my opposite is equal to 2.868 millimeters. But I can only have 2 digits, right? So 2.9 millimeters. Does that help you out? Perfect. Okay, the next one said 2. The igloo-shaped church in Inuvik was a historical building before it burned down in 2006. Sammy follows the path shown to arrive at the igloo church. Determine Sammy's displacement relative to his starting point. So he started here, he went 40 meters north, and then he went 60 meters east. What was his displacement? And the displacement is the shortest distance between start and end. So Rayleigh, I'm going to get you to calculate out this value, and Daniel, I'm going to get you to give me the degrees. And this is where we started. Yep. Kyle. Yep. So if I wanted to solve this angle, Daniel. Yep. It gave you which? It's going to give you second tan of 60, 40. I got 56.3. Is that what you got? Check your top. Are you in degrees or radians? There you go. Oops. Always make sure, especially those of you that are still doing Math 30, always make sure your calculator is in degrees when you're in physics class. We don't use radians. Rebecca? Okay, so what happens is this is our main axis, right? This line here, that's north. In order to go from north, we have to go east to get it. So it's 56.4 degrees east of north. What could we say? What's an easier way to do directions? The bearing directions, right? This would just strictly be 56.4 degrees because we start at 0 and we go clockwise, right? This would just be 56.4. That's like makes life easy, doesn't it? Can I move it? I'll just extend my. So when we go back to it, when we go back to significant digits, we have 72 meters, 56 degrees east of north. You could say 56.4. I will not mark you wrong. Answers will be like they'll say 56 degrees because there's two sig digs. If you told me 56.4, I would not mark you wrong. If you told me 56.42, I would take marks away. Because this is where he started. So this is the angle that I want to find. Always from where he started. Yeah. If you can solve it from where he ends, you would have been, what's 90 minus 56.4? You would have been 33.6 degrees north of east if you would have solved it where he ended. Right? Because here's east and you have to go north to get that angle. Okay, so I'm going to leave 4, 7, 5, and 6 for you to do for homework. Okay? Let's keep going. This is where physics, we got to pay attention. When we don't have the beautiful 90-degree angles, what we do is we break each line down into X and Y components. So this is where you got to be really good with being organized on your sheet. Okay? That's like a really big hint. Be really organized on your sheet. So what we do is we draw the grid lines on each vector and we break each vector into its X and Y components. And then you need to make sure you're paying attention to directions. North is a what? Positive or negative? East is? South is? West is? Make sure you know that. Do it. I don't care. Do this. Positive, positive, negative, negative. Just like that, so that you know, because it's going to become very, very important that you write down, am I north, am I south, am I east, or am I west, within my X and Y components. Okay? And then you add all the X and Y components together, and then when you get a sum total of X and a sum total of Y, then we draw a new triangle. And that one is 90 degrees. And then life gets easy. So we do a little bit of complicated math, and then we get real easy. I'll show you what that looks like. So make sure you let me know if you can't see what I'm working on, okay? So a dog ran 2 meters east and then turned and ran 4.7 meters, 38 degrees north of west. What is the dog's net displacement? So I know it says don't draw a picture right away, but I'll show you what that looks like. He ran east, and then he ran, if I put an X crosshairs here, he ran 38 degrees north of west. Right? Because this one here that's going to be my 38 degrees north of west. And so it's asking you, what's the dog's net displacement? There isn't a 90-degree angle in that triangle, in this one here. So it's telling you, write down your x component and your y component. So, step 1, he goes 2.0 meters east. My x component is 2.0 meters. My y component is, how much did he move in the y? He moved none in the y. He went due east. Okay? Step 2 is he ran 4.7 meters, 38 degrees north of west. So north, here's my west, and I gotta go north. So I go 38 degrees. North of west. Okay, here's where we get a little tricky. This is positive, by the way. Remember I said put your signs in? X component. What we need to do is we need to look at this angle and we need to create our own 90-degree angled triangle, right? This theta here is 38 degrees. This is my x and this is my y. And my hypotenuse is 4.7 meters. Okay? How do I solve for x? X is what? Adjacent or opposite to this angle? Adjacent. So here's my options. Of these three, how do I solve my x? Cosine. So x is going to be the cos of theta is equal to adjacent over hypotenuse. So I'm going to do the cos of 38 degrees is equal to adjacent over 4.7 meters. So my adjacent, when I go to rearrange this formula, what do I have to do? How do I isolate adjacent by itself? Times what? You're right, Cedric. Times what? 4.7. Absolutely, you can sit with Daniel and Rayleigh. You don't have to sit by 2 people per table. No, you don't have to. Got it? Pull a chair over. But CJ's right. You would multiply cos of 38 degrees multiplied by 4.7 meters. And so then I would get what for a value? Meters. Now my y is, what is y? Opposite or adjacent that angle? Opposite. So how do I solve for opposite? Right. Right? SOHCAHTOA. Sine is equal to opposite over hypotenuse. So then my opposite is going to be equal to the sine of 38 degrees multiplied by Thank you. And so my y is going to be equal to what? Sine of 38 degrees multiplied by 4.7. What do I get for a value? Okay. The next crucial step is we need to put values on these. X is going in which direction? Oh. X is heading west. What? Because it's north of west. So my X, to go from this starting point to where it lines up with this tail, I have to go west. So this value is negative 3.70365, blah, 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 blah. Okay? To go from my here up to my tip, which direction am I going? Up, north. So this is going to be a positive. What's your question, Cameron? A positive. Together. Let's look at page 136. Let's look at question number 1 together. Okay. A physics student walks 10 meters east from her locker to the rotunda and then walks 20 meters bearing 120 degrees, and they broke it down for you. They told you 120 degrees is 30 degrees south of east, or east 30 south, however you want to look at it. To get to the physics lab as shown below, determine her relative displacement to her locker. So it is asking us for this line right here. It's asking us to find this value right there. That's what it's asking us. Except that there is no right angle in here. None whatsoever. So we need to break it down into its two components. We need to look at this component here and then we need to look at this component here. Two different components. So for this one, this vector here, what is my x? Positive or negative? Okay. My y is what value? 0. Now let's look at this component here. Here they gave me the angle based on this being my triangle here. He said that this is 30 degrees. So this is x and this is y. X is going to be what? Oh, and this is 20 meters, this one here. This was 10 meters. X is adjacent or opposite to 30 degrees? Adjacent. So I just went straight without breaking it down. And right cos equals adjacent over hypotenuse. If I'm looking for adjacent, is equal to cos theta times hypotenuse. I just skipped over that. But if you struggle with it, let me know. I'll back up and go through it step by step. I don't have a problem with that. Okay, so that's my x. My y, is it? Just let it have its temper tantrum. My y, opposite or adjacent this 30 degrees? So what am I going to use? If I have these three things to pick from, those three things to pick from. Right, so the sine of 30 degrees multiplied by 20. What do I get for an x value? My calculator's done. Somebody has to tell me. $17.3025 meters. Now, is my x, so this is my direction. I'm going this way, and then I'm going this way. Is my x going to the east or to the west? To the east, so it's going to be a positive value. My y, sine of 30 times 20. What do I get for a value? Do I? Okay, I'm going to take Daniel's word for it. Am I going, now y, to go from this axis line here, I have to go down to this tip. Am I going north or south? South, which is positive or negative. So this is a negative value. Cameron. Throwing your hands up on which part? This one here, because to solve for x, x is adjacent or opposite of this angle right here. This one right here, this 30 degrees, this angle right here, is x adjacent or opposite? Adjacent. So cos is adjacent over hypotenuse. That's why I choose cos. Because we have to break this, remember, step one is to look at each of these lines in their individual vectors. So I highlighted it. Here's one line. Here's a second line. My first line is the pink, and then I don't worry about it anymore. And then my second line is the purple. So this triangle right here, this piece here, is this vector right here. And then I just drew in the x and the y phantom axis. Because when I take, it's okay, it's a good question. Here, cos theta is equal to adjacent over hypotenuse, right? We said that x is the adjacent. Yes, Daniel. We said that x is the adjacent, right? Okay. How do I isolate adjacent in this formula? How do I isolate adjacent? How do I move hypotenuse out of the denominator? So multiply by hypotenuse on this side, multiply by hypotenuse on this side. So cross those two out. I'm left with adjacent is equal to cos theta multiplied by hypotenuse. Right here, I did. How come I didn't do all the long work for? just because I was being lazy, Cameron. And I'm sorry if that caused confusion. Call me out on that, okay? So then the same process goes for sine. Sine is equal to opposite over hypotenuse. When I want to isolate for opposite, how do I move hypotenuse? How do I pull this out of the denominator? You have to multiply. So multiply by hypotenuse here, multiply by hypotenuse here. So that crosses out, and I'm left with opposite is equal to hypotenuse times sine theta, or sine theta times hypotenuse. It's the same thing. Okay? Okay. Step 1 is done. We broke them down into their individual vectors, and we found the x and the y values for each vector. Step 2 is do the totals. X total. So here, my x is plus 10. And here, my x is plus 17.3025 for a value of 27.3025 meters. My y total here, if you want, we could call it YA, XA, XB, YB. My y is 0 meters. And my second y is negative 10. So my y total is negative 10 meters. This is step 2 on our directions. Step 2, add all the x components together and add all the y components together. This is step 2. Step 3 says draw your x total and your y total tip to tail. So this is positive. So x is going to go this way. And then this is negative, so y is going to go this way. And then we draw our resultant vector. Because now we have a 90-degree angle, and Pythagorean theorem works beautifully. A squared plus b squared equals c squared. We can find our hypotenuse. We can find an angle much easier. We can do it here. How many people remember it's AB cos whatever minus something? Like, it's a big long formula. You can figure that out using A, B, and like sides A, B, and C, and angles A, B, and C. But it's super complicated. This is much easier. It's longer, but it's much easier. So R is going to be equal to, and I'm being lazy. I'm only going to write 2 numbers. You don't do that. 27 squared plus 10 squared. I'm going to take the square root of all of that. I'm going to get what for a value? Is he whispering sweet nothings in your ear? What do I get for R? Did I make a mistake? Yep, 27. I put a line through it for whatever reason. I don't know why. But you should be using 27.3025, blah, blah, blah. What'd you get?
37.
Well, yeah, I would say. Okay, just give me 4. 29 point. Okay. Now, because this is a directional piece, displacement is a vector. It requires a direction. We're going to figure out, here's where we started. We need to figure out this angle here. And opposite over adjacent is the information that we have. So tan negative 1 of 10 over 27 will be equal to my theta. So my theta is equal to, what'd you get, Avery? The theta? So in your calculator, you're going to go second function tan so that you get the tan negative 1. And then in brackets, you're going to go 10 divided by 27.3025. And then end bracket. R is this here. This is equal to R. You got 27? Point 3025. Ooh, is your calculator in radians? .20 what, Kyle? Was your calculator in radians, Avery? Yeah. I think that's the unit you guys are working in, so you got to really be conscious when you flip between the two classes, okay? All right, so now we got to go and we got to clean it all up, make a nice, neat, and tidy answer. What's the number of sig digs I have in this question? I got 10 meters east and 20 meters, 120 degrees. So I got 2 sig digs, 1, 2. So I've got 29 meters, 20 degrees. Now let's look at this angle. I'm heading east is my main axis. To get to this line, I have to go south. So it's south of east. Yeah. Bit of a struggle. That's okay. This is a first introduction to it. Cameron, do you see that a little bit better? No? Are you a thumb sideways or a thumbs down? You don't know? Got to process it. It's very, very important that you do this in the 3 steps. 1, look at each individual vector, not the triangle. And then step 2, you go for the total. And then in step 3, you draw the brand new triangle that we're going to work with. Because it's way easier to work in Pythagorean than it is to work in the other mode. Okay? So I want you guys, the rest of this is questions 1, 2, 3, and 4. So I want you guys to do that as well. And tomorrow we'll come back and we'll look at this. Okay? Because I think next one is projectile motion. Ooh, hey, wait. Projectile motion ends us off. Ooh, we are so close to being done. Oh, we got relative motion. Ooh. Relative motion is a little harder because it's in relation to something else. Figure out which way you're going. Yeah. Or relative to the shuttles. But even though the shuttle's going this way, what are you doing in relation to the shuttle? Yeah. Okay. Okay. Yeah. Yeah, I'll have religion at that time frame. 10. Oh yeah, Josie, Danica, Zoe, Carly. What do I out of here? There's Avery, Rebecca, and Paulina. Okay. Alrighty. That's your app.